We're going to perform some tests on a quadrilateral to determine whether it's a trapezoid. So, and again, with a trapezoid, one set of opposite sides is going to be parallel, and only one set of opposite sides will be parallel. And we will call the parallel sides the base, or bases, I should say, because they're plural. And then the other opposite sides are not parallel, and we call them the legs. Now, to be an isosceles trapezoid, these legs, the length of these legs must be congruent. So they're non-parallel, but they're congruent. The other pair of opposite sides, or the bases, will be parallel. So here we're asked to take a quadrilateral, QRST, and we're told that it has certain vertices. Q is at -8, -4, R is at 0, 8, S is at 6, 8, and T is at -6, -10. X and Y coordinates in the ordered pair. Show that QRST, whether or not it is an isosceles trapezoid. Well, let's see. Let's go here to the next slide. Now, other tests about whether a quadrilateral is a trapezoid would include that if a trapezoid is an isosceles trapezoid, then each pair of its base angles are congruent. But we don't know anything about the angles in this so far. And let's see, one pair of the congruent base angles. Oh, if it has one pair of congruent base angles, then it is a trapezoid. Well, we don't know anything about the angles. And then the diagonals, if the diagonals are congruent, then it is an isosceles trapezoid. But what we do know about this is do we have one pair of opposite sides that have the same slope? And those would serve as our bases. And then we check the legs to see if they're congruent. And if they're not, if the legs are not congruent, or if we don't have one pair of opposite sides that are parallel, well, it's a quadrilateral, but it's not a trapezoid. And it's not an isosceles trapezoid. I really should focus on all the more. All right, so let's see. Let's check the slope of QR first. So let's see, we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the slope of QR, we got a rise of 12, and we got a run of 1, 2, 3, 4, 6, 7, 8, rise of 8. Oh, and let's see, let's reduce this. They're both divisible by 4. So we got a slope of 3/2. All right, well, let's check then its opposite side, which is ST. ST. Well, let's check the slope on that. Down 1, down 2, down 3, down 4, down 5, down 6, down 7, down 8, down 9, down 10, 11, 12, 13, 14, 15, 16, 17, 18. So the slope of ST, we're down 18, and then we're to the left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. -12, well, the two negatives are going to cancel. Let's see, and 18 and 12 are both divided by 6. And so 6 will go into 18 3 times, and 6 go into 12 2 times. And they do have the same slope. So we can say that QR is parallel to ST. And I should put the little segment notation over there. Okay, so those segments are parallel. All right, what about RS, the slope of RS? Well, it's just a horizontal line up here. So it has a 0 slope. So the slope of RS is equal to 0. And the slope of TQ, well, let's see, we've got a run of -2. And we got a rise of 1, 2, 3, 4, 5, 6, 6 or -3. All right, so these, then that would mean that QR is our base and ST is a base and RS is a leg and TQ is a leg. So let's go to our second test, and that is the length. I'm going to make a better G right there. We're going to check the length of RS and TQ. Well, the length of RS, I could use my distance formula, but I don't really have to because I can just count this off on the coordinate plane. 1, 2, 3, 4, 5, 6. So that has a length of 6. Now, it's not quite as easy for TQ. I'm going to need to use my distance formula for that. So let's see. We're looking then to try to find TQ, the distance of that, and that's going to be equal to the square root of, let's see, what's my Q? -8 minus -6 squared plus my y coordinates. Q is -4 and T is -10 minus -10 squared. Square root of all that. -8 minus 6 for +6, and that's going to be -2 squared plus -4 plus 10, that's going to be 6 squared, which is now going to equal, let's see, square root of 4 plus 36, or the square root of 40. Well, that's definitely not 6, is it? Square root is not 6. Square root of 40 is not 6. I could simplify the square root of 40, though, because that's 40 times 10. So that could equal 2 square root of 10. All right, so here's our conclusion here. It is a trapezoid, but it is not isosceles. Even though our bases are parallel, our legs are not congruent because RS is equal to 6 and QT or TQ is equal to 2 square root of 10. Sorry about that, folks. It's a trapezoid, but it's not isosceles. The legs are not congruent, even though the bases are parallel. Shazam.